Okay, so this is Acids, Bases, and Salts, Lesson 2. And today we're going to talk about neutralization, which is an acid and a base forming a salt and water. Now, water will always be formed. Your salt will change dependent upon the acid and the base that you mix together. And neutralization is simply a special type of double replacement reaction. Two compounds, they switch partners. The only thing in this double replacement is that you will always wind up with a salt and water. So let's get started. In this first example here, you can see hydrochloric acid and sodium hydroxide mixed together to form water. So the easiest way to do this actually is to locate your H and your OH. Oh, I can't see that color. Let's get something a little bit darker. So there's our H and there's our OH. And that's what comes over here and forms water. And you can see what's left is your Na and your Cl. Recall from writing compounds that the Na, which is the positive ion, always goes before the negative ion. So it's just NaCl, which you see over here on the right. In the next one, we have sulfuric acid, and some base will yield potassium sulfate and water. And they want us to figure out the base. And the easiest way to do this, again, is to isolate your H, okay? And you know that this had OH in it to make water, so it's got to end in OH. And what would have gone together to make the salt? You have the sulfate, which you see here and here. So what's not accounted for is the K. So this had to be KOH. K is +1, OH is -1, so they combine at a 1-to-1 ratio, which is what you see here. And in the last example, you have nitric acid plus some base yielding calcium nitrate and water. Again, I know it's H, there's my OH, my base has to end in OH, and my nitrate is accounted for right there, so the missing ion is Ca. Now in this case, Ca has a +2 charge and OH has a -1 charge, so when I drop and cross, it actually has to be CaOH2. So you can see you're always going to form water, and your missing ions will form the salt, or if they're asking for the base, your missing ions form the base. Now we're going to move on and we're going to talk about titration. Titration is a process of acid-base neutralization. We can use titration if we know the concentration of either our acid and our base and a known volume that we're using to figure out the concentration of the missing reactant. Most of the time, we use an indicator called phenolphthalein, okay? Phenolphthalein is pink in the presence of a base, and it is clear in the presence of an acid. And your indicator table, table M, tells you that. The endpoint where we see the color change is neutralization. This is the point at which our H concentration, or H plus concentration, is almost equal to our OH minus concentration. The equivalence point is when our pH is exactly 7, and that is when our H concentration actually equals our OH minus concentration. So let's look at some problems. First of all, the formula that we're going to use is MAVA equals MBVB, and this is on the back of your reference table, and it tells you exactly what everything means. The molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And it's also written right here. What we have to remember is that 1 mole of H neutralizes 1 mole of OH to make 1 H2O or HOH. So as long as we have what's called a monoprotic acid, meaning 1H, like HCl, and a monohydroxy base, like NaOH, 1 hydroxide ion, then we have nothing to worry about. You'll see as we go through the examples, the problem becomes a little bit more tricky when our H to OH ratio is not 1 to 1. Okay, so in this first example here, it says how many moles of LiOH are needed to exactly neutralize 2 moles of H2SO4. So right away, I see in LiOH and H2SO4, my OH to H ratio is not 1 to 1. It is 1 to 2. So I'm going to have a problem. So I'm going to use my number of OH times my moles equals my number of H times my moles. So let's see what I'm going to do. I have 1 OH. I don't know the moles of LiOH. And I have 2 H's, and I have 2 moles of H2SO4 in the problem. So when I solve for this, okay, X has to equal 4 moles of LiOH. In the next example, how many moles of H2SO4 are needed to exactly neutralize 5 moles of NaOH? Here again, you see the same problem. I have a 2 to 1 ratio. I have 2 H's to 1 OH. So I'm going to go, my number of H is 2, and I don't know how many moles because that's what it's asking me to find. And I have 1 OH, and I have 5 moles of OH. So I have 2x equals 5, therefore x equals 2.5. And in the last one, it says how many moles of HCl are needed to neutralize 0.1 liters of 2 molar NaOH. Here, my H to OH ratio is 1 to 1. So if I've got 0.1 times 2, that's going to be 0.2. So therefore, I need the exact same amount. In this next problem, again, I can see that I do not have a 1 to 1 ratio on my H to OH. So it says how many moles of NaOH. So I have 1 OH. I do not know the moles of OH. I have 2 H's, and I have 0.2 moles of H. So I have 2 times 0.2, which is going to be equal to 0.4 moles. So X equals 0.4 moles of the base of the OH. So let's put what we just learned all together with the formula. It says how many milliliters. So right here, I do not know my VA. That's my question mark. Of 0.1 molar HCl. So that is my MA. Are needed to neutralize 40 milliliters. That is my VB. Of 0.5 molar NaOH. That is my MB. So I can straight out use my formula because my H to OH ratio is 1 to 1. So I'm simply going to substitute in MAVA equals MBVB. And I've got 0.1 times x equals 0.5 times 40. So I just have to solve for x. 0.5 times 40 divided by 0.1, and I get x equal to 1.2 molar HCl. Easy enough. That's because my H to OH ratio was 1 to 1. In the next one, though, notice it says it takes 10 mils, so there's my VA, of 2 molar H2SO4, there's my MA, to neutralize 30 mils, there is my VB of KOH. What is the molar concentration? So I don't know my MB. What I do realize, though, is that my H to OH ratio is 2 to 1. So I'm going to add that into my problem. So with my MAVA equals MBVB, I'm going to put my number of H and my number of OH. So I have two H's. The molarity of my acid is 2. The volume of my acid is 10 milliliters. I don't know the molarity of my base. My volume of my base is 30 mils, and I have 1 OH in KOH. So I've got 2 times 2, which is 4, times 10 is 40, divided by 30, which is going to be X equaling 1.3 molar KOH. All right, in the next problem, how many mils? So I don't know my VA, that is my question mark, of 2 molar H2SO4. There's my MA. Neutralizing 30 mils VA of 1 molar NaOH. There is my MB. So same thing, my H to OH ratio is not 1 to 1, it's 2 to 1. So you can see here, when I plug everything in, and I want you to do this, just like I did in this last problem, you should get 7.5 mils of H2SO4. In the last problem, it says how many mils of 0.1 molar CaOH2, so calcium hydroxide. So they gave us the base information first. So I don't know, I don't know my VB. I know my MB is 0.1, are required to neutralize 25 mils, so there's my VA, of 0.5 molar nitric acid. So there is my MA. So I want you to try to solve this on your own and then check your work. Realize that your OH to H ratio is 2 to 1. You have 2 OHs and 1 H. So pause it, do the math, and check back. If you did your math correctly, you should get 63 mils of CaOH2. All right, you are now set to go do the homework and then check the answers on Schoology.